Hello friends, welcome to the lecture of Applied Mathematics 2. Today we will discuss one more important topic of vector calculus, that is vector differentiation. So let's start. What is the derivative of vector? So first point, differentiation of vector. Let any vector, say vector u, is equal to f1 of t I plus f2 of t j plus f3 of t k, where I, j and k are unit vector along x, y and z axis respectively. Then derivative of vector u with respect to parameter t is given as, it is simply we have to differentiate each coefficient of I, j, k with respect to t. So it is df1 by dt I plus df2 by dt j plus df3 by dt k. So that is derivative of any vector u. Now next important point in vector differentiation is velocity vector and acceleration vector. So let us define velocity vector. Consider any curve in which suppose any particle is at point P. The position of this particle is given by position vector r with respect to origin O. Then the velocity is tangential at point P. So we will define velocity vector as vector v given by dr by dt, and we know that velocity is nothing but a rate of change of displacement with respect to time t. So that is our velocity vector. Now here let position vector r is given as xi plus yj plus zk, or it is x of t I plus y of t j plus z of t k. Then velocity vector is defined as dr by dt, which is equal to derivative of x of t, that is dx by dt I plus dy by dt j plus dz by dt k. So this is velocity vector at any point P. Now let us define the acceleration vector. We know that acceleration is nothing but rate of change of velocity with respect to time. Also it is equal to double derivative of r with respect to time, that is d2r by dt square. So it is equal to d2x by dt square I plus d2y by dt square j plus d2z by dt square k. Fourth important point here, consider any curve, then at point P, if this is position vector r with respect to origin, and as velocity is tangential, if particle moves along this curve, then after some time t, the particle will be at some other point, say q. If we'll join this point, then this will be r plus delta r. So in this case, we can find acceleration vector, but acceleration vector has two important component, that is one along the tangent, say at, and one along the normal, say an. At point P, the particle have two components, one along the tangent and one along the normal at this point. So acceleration vector has two component. First component, tangential component of acceleration vector, and the second, normal component of acceleration vector. So what are the formulas of tangential component and normal component? Let us see here. First of all, tangential component of acceleration is defined as vector at, which is equal to vector a dot product with unit tangent vector t, where t is unit tangent vector in the given direction, Now let us see the formula of normal component. The tangential component is equal to dot product of vector a and unit tangent vector t, but a normal component, that is an, is equal to cross product of unit tangent vector with vector a. So these are two important formula to find the components of acceleration. Now next important point, that is tangential component of velocity vector. Tangential component of velocity vector is similar to the tangential component of acceleration vector. So it is given as vt equal to vector v dot product with tangent vector t. Now let us see the solution. Let vector r equal to xi plus yj plus zk be position vector of particle along the curve. And here given that x equal to t cube plus 1, y equal to t square and z equal to 2t plus 5. Therefore the position vector are equal to xi plus yj plus zk. So it is t cube plus 1 I plus t square z plus 2t plus 5 k. In the given question, we have to find the component of velocity and acceleration. So let us find the velocity vector v here. So what is velocity vector? It is simply dr by dt, that is derivative of vector r. So it is equal to derivative of each coefficient, derivative of t cube plus 1, that is 3t square into I plus derivative of t square 2t j as it is plus derivative of 2t plus 5, so it is 2 k as it is. but at time t equal to 1, velocity vector will be 3i plus 2j plus 2k. Say equation number 1. Now acceleration vector is d2r by dt square, or it is equal to dv by dt. So differentiate the velocity vector with respect to time t. So it is 6ti plus 2j plus derivative of 2, which is 0. So it is 0k. But at time t equal to 1, acceleration vector will be 6i plus 2j plus 0k. Now we have to find the component of its velocity, and we know that the formula of component of velocity. Now component of velocity vector is given by, that is vt, that we have denoted it, which is dot product of velocity vector with unit tangent vector t, where t is unit tangent vector in the given direction, I plus j plus 3k. This direction is given in the question. Therefore unit tangent vector t is nothing but vector upon its magnitude, that is vector I plus j plus 3k divided by magnitude of this vector, that is 1 square, 1 plus 1 square, that is again 1 plus 3 square, which is 9. This is by definition of unit tangent vector. Therefore velocity, therefore component is of velocity vector, that is vt, is equal to vector v, which is 3i plus 2j plus 2k dot product with unit tangent vector, which is I plus j plus 3k whole divided by square root of 11. Now we have to do the dot product of these two vector, and we know that by definition of dot product we have to multiply the coefficient, that is 3 into 1, which is 3, plus 2 into 1, that is 2, plus coefficient of k 2 into 3, which is 6, divided by root 11, which is equal to 11 divided by root of 11. So it is square root of 11. Now second we have to find component of acceleration vector, which is equal to vector a t, as dot product of vector a with unit tangent vector t. And in this given example, vector a is 6i plus 2j plus 0k dot product with unit tangent vector t, that we have already find here. So dot product of I plus j plus 3k divided by square root of 11, now which is equal to Dot product of these vector with these is equal to, again, 6 into 1 6 plus 2 into 1 2 plus 0 into 3 0 divided by root of 11, which is equal to 8 divided by root 11. So this is example based on component of velocity and acceleration. Now second example is for you for practice, but I am giving here hint for you. So what is hint? First of all, pause the video and read the question carefully. So here hint is that in previous example we have to find the tangential and normal component of velocity and acceleration in the given direction, but here direction is not given. So in order to find the unit tangent vector in the given direction, as the direction is not given, you have to take the direction of velocity, because velocity vector is always tangential to the path of the curve. So it is vector v upon its magnitude. Now you have to complete the whole question like previous example. So thank you for watching.